Hello and welcome everyone to my channel Code with Ease. Today we are going to discuss a very popular question as part of the array series. It is called Best Time to Buy and Sell Stock. Hi, here's a brief introduction for the ones who are new to the channel. The objective of Code with Ease is to make problem solving in programming simpler. If you are someone who wants to become a great developer and wants to level up their skills, data structures and algorithms is indispensable and you need to form a solid foundation of that. And this is exactly where we come in. Because we post topic-wise video explanations in Java on various coding interview questions that can not only help to crack the coding interview, but also help to improve and refine the problem-solving abilities as a developer. And finally, here is the USP of our channel. We code every solution live, we do not copy-paste code snippets. We start off by clearly defining the problem statement, the given inputs, the required output, time and space complexities. We also then discuss the brute force way of solving any question without jumping on to the solution and then gradually move on to the optimal solution. We try to use online whiteboarding wherever applicable to explain the approach and the concepts. So that is all about us. So if you guys also want to be a part of this journey, do support us by subscribing to the channel. So with that, now let's get back to the question. In this, we are given this array prices where prices of I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and then choosing a different day in the future to sell the stock and return the maximum profit that we can achieve. If you cannot achieve any profit, you have to return 0. Okay, so let's take a look at this example. Here we have this array in which the different prices of the stock on every day is given. Like 7, first day it was price was 7, then it went down to 1, then it again rose up to 5 and 3 and so on. It is saying that the output is 5 because if we buy on day 2 when the price was 1 and if we sell on day 5 when the price was 6, then profit achieved was 5 and that was the maximum profit that could be achieved. In the second example, however, we are seeing maximum profit is 0 because it seems there was no day in which they could buy at a lower price and sell at a higher price. This is the intuition behind buying stocks. Like we try to buy a stock at the lowest possible price and we want to sell it off at the highest price possible so that we can maximize the profit, and that exactly is what we have to try to solve in this. The intuition is very simple. We have to buy at a lowest price and we have to sell it off at a higher price. So now let's move to the whiteboard to understand the brute force way of solving this, and then gradually we'll move to optimal way of solving this. So now we are going to discuss the approach for solving this. So this is the time and space complexity that I have noted, and this is the array on which we are going to do a dry run. And at first we are going to discuss on the brute force way. So as we told, what is the intuition behind this? Buy at a low price and sell at high price. And of course sell it on different day. This is the intuition. Now with this, let us try to understand. So what is the naive way of thinking? We will use loops. Obviously we have to traverse, so we'll use a loop. And in the first loop, outer loop, which is going to run from, like, let's say I equal to 0 to n. In this, we are going to track the buy price. I'll just write CP, the cost price. And then we can have another loop, the inner loop. This is the outer loop, this is the inner loop. And this, we can maybe start from j equal to 1 to again till the end. In this, we are going to track the selling price. So how will it be? Suppose outer loop is at 7. This is the outer loop, the I pointer. And then inside this loop, we are going to check whether, like, if I'm buying at 7 and if I'm selling at 7, what is my max profit? We'll have this variable max in which we are going to store. So if I buy at 7 and sell at 1, obviously my profit is going to be negative. In that way, I'm going to check for each of the variables. So whatever will be the maximum profit, that will be stored over here. Then I'll move to the next element. So now 1 becomes the buying price and others 5, 3, 6, 4 will be the respective selling prices on each of the days. And then I'll calculate if the maximum profit achieved is greater or not. If only it is greater, then I'll store it in the max variable. So that is the simple plain way of thinking in which I'll use two loops. The first loop is going to track the cost price and the inner loop will track the selling price, and that I'll do an entire traversal of the array. And wherever my maximum profit will be, like the maximum profit is achieved, that max we have to just return. So as we can understand from this, the biggest problem is the time complexity, that we are taking two loops, two traversals, exponentially it is going to increase. Of course, we can try to optimize the inner loop by not checking I with every j, but it can be something like we will check if ARR of I, if this is lesser than ARR of j, only then do the comparison, because we don't want to sell it off at a lower price, right? We want to only sell it off when j is greater, when the ARR of j is greater. So yeah, that is one thing which we can do. Still, two loops are needed. This was the first approach. What is the second approach? Maybe we can try to use some space. So as we can understand from this, we want to buy at low and sell it off at a high price. So if I'm buying at 1, like it was given in the example, the selling price was 6. In that way, 5 as the maximum profit was being achieved. It means what? We want to sell off at a higher price, and when that higher price is going to come, obviously we have to buy first and sell. It cannot happen other way around, like first we will sell and then we will buy. So at first we have to buy, means when we are coming from the left hand side, first the buying price has to be decided. Going towards the rightmost end of the array, we can decide what can be the selling price for this. So in that way, if I want highest selling price, I can use some space to keep track of how high the price went. How high the price went by using one extra auxiliary array. In that, I can just keep tracking from back how high the price would go up. So whenever we try to use additional space, it is called array preprocessing. So this is the original array. So based on this, I have written this another new array. This is the auxiliary array. This new array is basically going to track how high the price has been, like what is the maximum selling price it can go, what can be the maximum price the stock can go up to. This is like, we can consider this like the max price so far. This is something like that. Once we get hold of this new array, now we will traverse the array. In one traversal only we are going to solve. How? First we will come at 7 and then we will subtract, like 7 minus 7, 0 profit. So we'll move on. Now let's say I am at 1. So 1, then 6 minus 1, I am getting a positive profit. So I'll store this. So I'll just subtract these two values at the respective indexes. Like 6 minus 1, profit is now 5. So I'll store this. Then again 6 minus 5, profit is 1. Is it greater than 5? No. So I will not change my math. So what is now happening is, now that we have got hold of this auxiliary array, now this becomes our new selling prices, like the potential selling prices. And the original array is just for tracking the buying price. If I am buying at 7, selling at 7, no use. If I'm buying at 1, selling at 6, it's useful. If I'm buying at 5, selling at 6, again, lesser profit. I will have profit but lesser profit. Similarly, I'll just have to manipulate this max variable in just one single traversal. Using additional space, we can also solve this question. Again, what is the problem? We are using O of n space, which we do not want. This was the problem of second approach. Now let's go to our final approach, in which now we have to optimize this. What we have to optimize? Let us not take any space and let us try to solve this in one single traversal only. So what will be the algorithm for this? If I have to do it in one single traversal, now I'll just do a reverse concept of this. In this, what we were doing in the auxiliary array, we were tracking how far the price could go up. Now what we will do is how minimum the buying price can be, or I can say the thing is like minimum price so far. This is going to be the new variable that we will use while traversing, and this is the variable which we are going to populate just to track that what is the minimum price so far. Now what we will do, the reverse approach. Now when we are going to traverse the array, this original array, now when we are going to traverse this array, now instead of seeing every element as a potential buying price, now I will see every element as a potential selling price. So now these elements are going to be my potential selling price. And I will anyway have this variable min price so far. So I'll come from left side and I'll say, what is the minimum price so far? So initially minimum price so far will be 7, and I'll also take another variable called the max profit, which will initially be 0. Why 0? Because as there was a condition that if there is no profit at all, we have to return 0. So by default, I'm setting this to 0. So now this will be set to 7. When this is set to 7, now what we are also doing is we are calculating this max profit. This max profit is going to be math.max of already whatever the max profit we have in this and the ARR of I, means the current element, minus the min price so far, min price. So this we are considering as the SP and this is the CP. So initially when my min price so far is 7, max profit is anyway, initially it's 0. So ARR of I am currently at 7 only, min price so far is also 7. So 7 minus 7, 0. So max profit is 0, unchanged. Now I'll move to 1. Now min price so far has become what? Now min price so far, we are going to calculate this inside the loop. Min price so far is what? Min price so far will be math.min. What about the minimum? Minimum of this price, min price, or the current element. Like current element now is 1. Earlier our min price so far was having 7, but 1 is smaller. So this will change to 1. So min price so far becomes 1. Now if min price so far becomes 1, now I have to try to calculate the maximum profit over here. So now again same thing will happen. Max profit, earlier it was 0 and 1 is there, and 1 minus 1 is going to be 0. So no use. But the only good thing is we have initialized this min price so far. Now it was going to move to the next element. Is 1 smaller or 5 smaller? So min price so far will remain at 1 only. So now think of this as 1 has become my fixed buying price because it has become like the minimum. So I'm going to buy at price equal to 1. So now min price will not change. Max profit it is trying to calculate. So 5 minus 1. Now the max profit is becoming greater than 0. So max profit is going to become 4. Good enough. So we have got some profit. Great. Next it is going to move to 3. Again 3 is not smaller. So min price so far will still remain as 1. Now it is going to recalculate 3 minus 1, which is 2. 2 is smaller than the maximum profit what we have achieved. So that is why we are not going to change the max profit. Now I'll come to 6. Now again, min price so far will remain unchanged because 6 is greater. Max profit, in this case it will be 6 minus 1. 6 is the current element, min price was 1. 6 minus 1 is 5. So 5 is greater than 4. So now my max profit changes to 5. So in this way, we are maximizing the profit. And at last, it will go to this element. And min price is 1. So 4 minus 1, 3. 3 is lesser than 5. So ultimately, 5 is going to be our output. So in this way, I've explained the algorithm, the pseudocode, and also the dry run. All three things done in one shot. So with this, now let's see how to implement the code for this. Now let's start with the code implementation for this question. First of all, let's initialize the max profit. Then we'll also initialize this variable called min price so far. Now we'll do the first check. So now inside this variable min price so far, we are going to store the math.min of the current price, that is prices of I, and this variable itself, whichever is lower. Since we have initialized this to integer.max value, which is integer.max value, so that is why in the first run only it is going to initialize this min price so far to the first element. And then we will calculate the max profit. To calculate this, we will use the math.max function. So in that, max profit will either be the max profit whatever we have already, that or the current element which is prices of I minus the minimum price so far. Like we discussed, prices of I is the potential selling price and minimum price so far is the potential buying price. So a difference of that will be our max profit. Initially, we are setting this to 0 because if we cannot achieve profit, we anyway have to return 0. If at all we get any profit which is greater than 0, then this max profit variable is going to be initialized with that amount. And finally, we just have to return the max profit. That's about this. So we'll run this. So yeah, that's all about this question, best time to buy and sell stock. There are multiple versions of this question as it is available. So which we are going to see in the upcoming sessions also how to do that. Do let us know in the comments below if you guys have any questions or doubts or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.